Alright, our first problem here, x is less than or equal to 4. Remember that when you have the line under your inequality sign, that means equal to. So this one is x is less than or equal to 4. So when we graph that, first of all, you just always go to where your number is. So in this case, it's 4. And you go to 4. And then you just draw a line either going bigger than 4, so it could go that way, or less than 4. And in this case it says x is less than or equal to 4, so the line is going to go that way. So I'm going to go ahead and draw my line this way. Okay. And then since it's less than or equal to, it could also be 4, so I want to draw my circle around 4 and shade it in. So x is less than or equal to 4. And that's all you do for those. Okay? And do keep in mind, I did shade in on the number 4 because it can also equal that. So x is less than or equal to, so I shaded in 4. Another way to remember that is to write this less than or equal to sign, you had to use extra ink or lead in your pencil to write the line underneath, so you also have to use extra ink to shade in your bubble, and this will make more sense in a second. So our next one reads x is greater than negative 3. X is greater than negative 3. Okay, so again we're going to start now at negative 3 and go to negative 3, and you can start by circling negative 3 here. Having a few issues here. Circle negative 3. And it's not filled in, and then x has to be larger than negative 3, or x is greater than negative 3, so our line is going to go this way. And it goes on and on because it's any number larger than negative 3. Since there is no line under our inequality sign like there was here, we do not fill in our bubble, so there should be a big open space there because x cannot be negative 3. It has to be larger than negative 3. So we don't fill it in. Notice here, because it was less than or equal to, we did fill it in. So then on this third one, x is greater than or equal to 2. So x is greater than or equal to 2. Again, we're going to start where our number is, so 2. And just going to go ahead and there's 2. And I didn't fill it in. We're not going to do that yet. But x, again, is greater than or equal to 2. Okay? So it has to be larger than 2 for sure. So I'm going to go ahead and draw my line larger than 2. Okay? And since it can also equal to, because we have that line underneath, since it can also equal to, I'm also going to fill it in, just like I did on the first one. So this time I'm going to bubble it all the way in. So on the first one we filled it in, on the second one we didn't because there was no line underneath. There was a line here, no line here, so we don't fill it in. And here we had a line underneath, so we need to fill it in because it can also equal to. So x is greater than or equal to 2. And then on this last one, x is less than negative 1. Again, I'm going to start at negative 1. Draw my big open circle. Always start with an open circle. And then x is less than negative 1. So I need to any number less than negative 1. Now in this case, it is not less than or equal to. It's just less than negative 1. So we do not include negative 1. So we keep the bubble around negative 1 open, just like we did on the second one. So that's how you do those problems. Alright, so now on these we're going to actually just do the opposite of what we did on the last problem. So we have graphs here, and we're going to go ahead and turn them into an inequality statement here. So what we're going to always do here is we're always going to use x because it says use the variable x. Okay, so on all these problems you're going to write x. Okay, and then you're going to write the number that the graph is plotted. So in this case, in this first one, it's plotted at 3 because the circle is over the 3. So the number we're comparing x to is going to be 3. Okay, so now we just have to decide is x less than or equal to or is it larger than or equal to 3? Well, in this case, if you look, all the numbers, didn't mean to do that. All the numbers are getting smaller than 3, so that means that x has to be smaller than 3. So we write smaller than, so we're going to have the point, or the arrow like going towards the x, that small point. Okay, but you're also going to notice that the line is filled in, which means that it's not just smaller than 3, x is not just smaller than 3, but because it's filled in and not open, it can also be equal to 3, so it can be 3. So to show that with our inequality sign, you put a line underneath. So that reads x is smaller than or equal to 3, okay, because all our numbers got smaller than. Now that could also be written like 3 is larger than or equal to x. Either way is fine. It kind of confuses me to switch the order that I write them in, but do know that you could read this backwards. So 3 is larger than or equal to x, so you can also write it like 3 is larger than or equal to x. Okay, so on all those you could flip them. Alright, on number 2 here, on example number 2, we have this problem here. We're starting at -1, so we're going to have x, and we're going to have -1. And again, you could write this the opposite way, but I'm going to do it this way. X and -1. And it looks like all the numbers, I did not mean to do that. It looks like all the numbers are getting larger. So you're going to go ahead and say x is larger than -1, since the arrow is going to numbers that are larger. Okay? And then in this case, it is not filled in, which means it is not equal to -1. So we're not going to put a line underneath like we did up here. We're just going to leave it. X is greater than -1. It is not -1, it's just any number that is bigger than. Okay. Again, you could rewrite it -1 is less than x if you wanted to, but it's probably a good habit to just get writing it one way. Okay. And then on number 3 here, we're starting this time at 0. So I'm going to go ahead and write x and 0. And it looks like all the numbers the line is going smaller than, all those numbers are smaller than 0 or less than 0. So I'm going to go ahead and write x is less than 0. And again, our line is not filled in, or our bubble is not filled in, so it is not, x is not equal to 0. It has to just be smaller, so I'm not going to put a line underneath. Okay. And then on that last one, on this problem, you have -2 that we're working with. So it's going to be x and -2. And if you see, the line is going bigger, so larger. All the numbers are going to be larger, so x has to be larger than -2. Now in this case, it is bubbled, which means x can also be -2. So x is larger than or equal to -2. So we have to put that line. And again, another trick to thinking about that, if you put the extra ink or lead into filling in the bubble, you need to put the extra lead or ink into putting a line underneath. That's kind of a trick to remember in that. Okay? So hopefully this will help you guys be successful on your homework. Alright, so we're getting pretty close to finishing up here. So on these we're going to write inequality statements from an example, and I actually think these are a little easier because you have like a scenario to go off of. So on this one we have, write an inequality for every item costs $1 or less. So every item, we don't know how many items, so let x be items, but every item costs $1 or less. Okay, so we're going to go ahead again. You're going to have x for item, and then it's $1. So you could just put 1, or you could put 100, 0.00, it's up to you. But every item costs $1 or less. So x is going to be less than $1. That item is going to be less than $1, but it also says every item costs $1 or less. So it could also be $1, so it could be equal to $1. So it needs to be x is less than or equal to $1. Okay, so we do need that line there. So that part's a little tricky. Remember, you have to include the $1 because it's every item costs $1 or less. Okay, so that's that first one. On The second one, I didn't give myself a lot of room here. It says, write an inequality for the temperature is greater than 100. So the temperature is greater than 100 degrees. So it says use T for temperature. So the temperature has to be larger than 100 degrees. Okay, and we know our larger than, so T for temperature, the temperature is larger than 100 degrees. Now in this case, it doesn't say the temperature is 100 or larger, it has to be larger, so it's not equal to 100, so we don't put the line underneath. Okay, so that's how you do those ones. Alright, last one before homework. Okay, so on this one, it's actually just a multiple choice question, so maybe a little map test practice here. So let's read it and then read all our options and see which one makes sense. So it says the maximum weight an elevator can hold is 800 pounds. So the maximum weight it can hold is 800. Which inequality describes this situation? So W must stand for weight. So the most it can weigh is 800. So this one says the weight has to be less than 800. This one says the weight has to be less than or equal to 800. This one says the weight is greater than 800, and this one says the weight is greater than or equal to 800. Well, the maximum, so the most it can weigh is 800 pounds. So it cannot be greater than 800 pounds. So neither of those could possibly be correct. So I'm going to X those out right away. But on A and B, it says the weight, on A it says the weight is less than 800. Okay, here it says the maximum weight an elevator can hold is 800. So that one seems possible. And this one says, again, the weight is less than or equal to 800. If you notice, it says the maximum weight of an elevator can hold is 800 pounds. So it can be 800 pounds. So this one, the weight is less than or equal to, it can be 800 pounds. So that one would work. The problem with this one is it's saying it has to be less than 800. It can't be 800. So that one also can't be correct. So by trial and error and by reading these really carefully, B would be your correct answer.